Can the lithium battery pack still be used normally after a short circuit? Firstly, let's clarify what a short circuit is. When there is no load connected, the positive and negative poles of the power supply come into direct contact, forming a circuit. At this time, a large amount of current is generated and often accompanied by sparks. Hey friends, thanks for joining me. Welcome to the channel. If you're new here, my name is Will. Come for the lithium battery tips and stay for the short circuit problems of the lithium battery pack. According to Ohm's law, current is equal to voltage divided by resistance. In lithium batteries, the larger the capacity, the smaller the total internal resistance of the battery. Without the load, the short circuit current is equal to the voltage of the battery itself divided by its resistance. If a voltage of tens of volts is divided by a resistance of tens of milliohms, the current can easily reach tens of thousands ampere. The energy generated by such a large current is enormous and also extremely dangerous. So what to do if a lithium battery pack cannot be used normally after a short circuit? Well, two situations. In the first case, the BMS is burned. Perhaps you may wonder that since lithium batteries are equipped with BMS, which also have short circuit protection functions, why are they still burned when there is a short circuit? This problem is not actually complex, because the short circuit protection current that the BMS can withstand also has an upper limit. Exceeding can cause damage to the BMS. Here's an example. We have a two-wheeled electric vehicle with a motor power of 400 watts and a set of 48 volts 100 amp hour high-capacity lithium batteries. The maximum current of this electric vehicle during driving will not exceed 20 ampere. According to the matching formula of a BMS, a 20 ampere BMS is sufficient. There's indeed no problem with normal use, but this battery is equivalent to have no short circuit protection function because the internal resistance of a 100 amp hour capacity battery is very small. The short circuit current will be very high. If the upper limit of the short circuit protection current of a 20 ampere BMS is calculated at 3 times, it's not yet 100 ampere. So in the moment of a short circuit, the BMS will be burned. The higher the rated current of a BMS, the greater its ability to withstand short circuit current. So, if the battery above wants to have short circuit protection function, it needs to be equipped with a larger ampere number BMS. Of course, matching BMS with too much current is also not good. Otherwise, even if the batteries are on fire, the BMS short circuit protection will not be triggered. In the second case, the BMS activates short circuit protection, and at this time, the battery cannot continue to discharge in use. When short circuit occurs, the BMS will cut off the power supply within 20 microseconds, thereby avoiding high current from burning the equipment and providing protection. The load needs to be disconnected in order to recover. This is very important. There are many batteries connected to the BMS, such as DC to DC charging for mobile phones, voltage display, and GPS. These are small loads, and the BMS will not recover until they are completely disconnected. To summarize, if a group of lithium batteries is short-circuited, it may not necessarily be broken. Multiple analysis is needed to identify the cause of the problem and solve it. Okay guys, this is the end of today. Hope you like it. If you have any problems, please leave the comments below and see you next time. Bye.